And we're going to talk about basic area formulas. The first thing I want to start with, though, is it perimeter? I'm not going to talk about a lot of formulas. We're not going to talk about formulas for perimeter, but I just want to talk about the idea. So when we say perimeter of some shape, what do we mean? What are we talking about? Yeah? Yeah, how far around the outside? So that's going to be just fine for our idea for perimeter. And the way we're going to calculate perimeter, we're not going to come up with a lot of formulas, but just what in general, how would we calculate the perimeter of something? If we have several sides, what do? Just add up all the sides. That's all we're going to say for perimeter. Add all sides, and I'm going to just put around the outside. So I don't want people thinking, oh, I need to add every single side. We're just going to add around the outside. So we're not going to write down formulas for perimeter. We're just to find perimeters, we're just going to add up all the sides around the outside. And that's going to be for any shape that we talk about. All right, so let's talk about our areas. For a square, we'll start with a square. Whoops, S-Q-U-A-R-E. Square. Let me get a picture here of a square. And we know for a square, all the sides are the same length, and all of our angles are 90 degrees. And I'm going to call the side of the square, the length of the side, S. So for a square, how do we find the area? Well, just in everyday thinking, how would you think about finding the area of that shape? Yeah? Well, that would be the perimeter. So we'll talk about that in just a second. We want the area. Okay? S times S, and let's go like kind of one step more basic. How do we think of finding the area of a shape like this? Someone said something with a base and a length times width, or base times height. So I'm going to say I can write that length times width, that works. Or base times height, that'll work too. For a square, the length and the width are the same. They're both S. So I'm going to say that the area for a square, these will work. That's fine. I'm going to write it as S times S, which is S squared. And for area, we're going to use units. Our units for area are going to be units squared. So inches squared, meters squared. The other way you can say it is square inches, square meters. So we want to include our units when we're talking about area. And then our perimeter, just add up all the sides. So we'd have S plus S plus S plus S. We'd have 4 of those. But we're not going to bother writing down formulas for perimeter. We just add all the sides. Oh, and let me write up here for perimeter. Our units are just units. Inches, meters, centimeters. So perimeter is going to be a length. All right, so there's our first basic area formula. How about a rectangle? We draw a picture of a rectangle. There it is. I want this. Okay. And we know for a rectangle that the opposite sides are the same, and all of these are 90-degree angles. Did you hear about the shapes that got in a car accident? They're rectangles. It's okay though. They're all right. All right. Area. How do we find the area of a rectangle? Yeah. Length. Length. Not quite. Not quite. We're on the right track with the first part. Base times height. Sure. I can call this B and this H. So our area is going to be base times height. We could think of it as length times width also, just like the square. And our units are going to be units squared. Square inches, square meters, something like that. And our perimeter, just add up all the sides around the outside. Okay, let's move to our next shape. Are we good with a rectangle? How about a triangle? So let me draw a generic triangle. Nothing special, no special kind of triangle here. So for a triangle, what is, yeah?
Base times height divided by 2.
Base times height divided by 2. Area, I'm going to call this the base. And just a reminder, the height has to make a 90-degree angle with the base. I'm going to say base times height divided by 2. And our units are going to be units squared. Square inches, square meters, something like that. Perimeter, we have to add up all the sides around the outside. So somehow we'd need to get some information about the other two sides for a triangle to find the perimeter. All right, our last basic shape. Circle. Circles are nice because really there's only one piece of information that we need to know, the radius. So do we remember the formula for the area of a circle? Yeah, true. Yeah. Uh-huh. Pi r squared. Nice. So our area is pi r squared, and our units are square units. I'm going to write in draw in one other thing. So that's a radius. All the way across is a diameter. Now we give the perimeter of a circle a special name. The circumference. And just a little side note, I've been working on a master's degree in math, and I had an assignment once where I said a hexagon had a circumference. I talked about the circumference of a hexagon, and I lost points on that because the grader said hexagons don't have circumferences, they have perimeters. Yeah, so I lost a couple of points for saying that. Just so you know. And so we have a formula for the circumference. We can't really add up all the sides of a circle. The circle just has one side, but it's curved. So we have a formula for the circumference of a circle. We remember what that is. It has a pi in it. Pi times the diameter. And our units are going to be units. Well, how many radiuses make up the diameter? 2. So we can also write that as circumference equals 2 pi r, because the 2 r's give us a d. So our circumference, we can find our circumference that way as well. So those are the basic area formulas we're going to work with today. So what I want to do is a couple of examples with circles, because your book is going to ask you for your answers in a certain way. And I want to show you, make sure we understand that. What's that?
I'm sorry, I was reading that sign up there.
About deadlifting? Or about the
Every
puppies?
time you do a math problem, a puppy does.
No. It's a math mistake. Every time you make a math mistake like that, a puppy dies. Okay. All right. Let's look at an example. We want to find the circumference and area. Now, I think doing math problems actually causes puppies to be born. So that's how good the math problems just are that much good. All right, I'm going to say this is 12 inches, and we want to find circumference and area. Well, the circumference, they give us almost everything we need. The circumference, this is the diameter. So the circumference is pi times 12. I'm going to write it this way. 12 times pi, just a different order. And I'm going to say inches. If the problem was given to you this way and it said answer in terms of pi, this is what they're looking for. You leave pi in the answer. So this is in terms of pi. So they're just asking you, don't multiply it out. And the reason that you do that is because the symbol pi contains all the infinite number of decimal points that are in pi. So we call that the exact answer. If the problem said round to the nearest tenth, in my calculator I would do 12 times, and you can use your pi button, or I'm just going to do 3.14, and I get about 37.68 inches. This would be, well, let me round this. So I'd round this to 37.7. This would be rounded to the 10th. So they'll ask you for the answers in different ways. Sometimes they'll say leave your answers in terms of pi. Sometimes they'll say round to the 10th or the 100th. All right, let's look at the area. The area we know is pi times the radius squared. What's the radius? 6. Got to be careful. Pi times 6 squared. And I'm going to write that in terms of pi. I would just square 6. And I would say 36 pi square inches. And if I wanted that rounded to the 10th, I would multiply 36 times 3.14, and I get about 113.04. If I rounded to the 10th, that would be 113.0. And I'm going to put a squiggly equal because this is approximately equal. So this first answer is my answer in terms of pi. The third answer that I put there would be rounded to the 10th. This would be rounded to the 100th. All right, questions on that example? Okay, I want to do another example with circles where we kind of work in reverse. So we say the area of a circle is 38 square inches. Find the radius. So we know the area, we want to find the radius. Well, this is kind of like the last problem, but we're working in it the opposite direction. We know that the area is pi r squared. It tells us the area is 38 inches. And I'm solving this equation for r. So what's the first thing we want to do here to solve for r? And we remember pi is just a number. What do I want to do to get the pi away from that r squared? Yeah? Divide. So we're going to divide everything by pi. We can do that. Pi is just a number. Pi divided by pi, those cancel out. Anything divided by itself is 1. And I'm going to divide 38 by 3.14. And I get about 12.102. And I want to find the radius. This is r squared. So how do I undo that square? Square roots. We're going to take the square root of everything. So r equals, and I'm going to put that in my calculator, square root of the answer. And I get about 3.5, rounded to the 10th. My radius would be 3.5 inches. We kind of work the problem in reverse. All right, questions there? Okay, sometimes you'll be given problems with coordinates. So let's say we have a triangle and they give us the coordinates of the vertices. So it's either on a graph or they give you the coordinates something. And I'm going to say this is -4, 3. This is -4, -5. And this is 2, -5. And they want to define the perimeter and area. So we need to find some lengths of sides. But I'm going to look at these coordinates first. The segment from -4, -5 to -2, -5, since the y's are the same, it doesn't go up or down. This is horizontal. So if it were on a graph, if I had I'll just sketch a little graph over here. This would look like, this would be a point here, and this would be a point here, and it would look like that. And this goes from -4, -5 to -4, 3. It goes straight up. That's vertical. So my triangle on my coordinate graph would look like this. So this is a 90-degree angle. So we can treat this like the base and this like the height. Well, how far is it from -4, -5 to 2, -5? 6 units. We're going from -4 to 2. That's 6 units. How far is it from -4, -5 to -4, 3? 8. We're going up 8 units. So our area is 8. I'll do it the other way. Base times height, 6 times 8, divided by 2. So I get 12 square units. To find my perimeter, somehow I need to find the length of that side. I have a couple different ways that I can do it. We said this is a right triangle. What always works for a right triangle? What's a special thing we know about the sides of a right triangle? Has some A's and B's and C's in it. A squared plus B squared equals C squared. The Pythagorean theorem always works for a right triangle. So I can call this side C, and I can say, I'll keep this side as B. So 8 squared plus 6 squared equals C squared. The Pythagorean theorem always works for right triangles. Well, 8 squared is 64. 6 squared is 36. And this turns out nice because 64 plus 36 is 100. And to find C, we take the square root of both sides. And C equals 10. Mm-hmm.
The area of 48 divided by 2 is supposed to be 24.
Yes. Thank you. See, when I make mistakes like that, I'm seeing if everybody's paying attention. Hands up, paying attention. Thank you. All right, now we can find our perimeter. Our perimeter is 8 plus 6 plus 10, which is 24 units. It just happened by chance that they're the same number. If we didn't remember the Pythagorean theorem, what's another way we could have found the length of that hypotenuse if we have the coordinates of the endpoints? Didn't we do that problem for our opener? Didn't we have the endpoints of a segment and wanted the length? You can also use the distance formula. So let's look really quickly at what happens with the distance formula. I'm going to call this x1, y1, x2, y2. I'll do that over here. The distance is the square root of y2 minus y1, negative 5 minus 3, squared plus x2 minus x1, 2 minus negative 4, squared. Do we see what's going to happen? Negative 8 squared plus 6 squared. The square root of 64 plus 36. Square root of 100. 64 plus 36. They're the same thing. And we said the distance formula comes from the Pythagorean theorem. So once we get past here, you end up with the same numbers. So you can do it either way. Now, if it were not a right triangle, you would have to use a distance formula. Okay, we're good with that example. Okay, the last one. What if we had a non-standard shape? Something like, I don't know, plans for a house or something like that. And let's say that I know that this is 20 meters, and this is 12 meters, and this is 16 meters, and this is 8 meters. And we want to find perimeter and the area. And I look back at my formulas and I say, I don't have a formula for the area of that kind of L-shaped thing. So what do we want to do here? Mm-hmm. We can divide it up. So I can divide, I'll just divide it this way. So we divide it into rectangles. I wouldn't want to do it. You could, but I would not advise to divide it into circles because it doesn't work nicely. You could divide it into triangles, but that's going to make your life difficult. So divide it into some rectangles. Okay, now we're okay. This piece is 12 times 16. That's just a rectangle. And 12 times 16 is 192. Well, we're missing a side here. I need this length to find the area of this thing. Yeah?
20 minus 12.
20 minus 12. This whole side is 20. This piece of it's 12. So that leaves 8 for that. 20 minus 12 is 8. So this side has to be 8 meters. So this area is 8 times 8. 64 square meters. So the area is 64 plus 192. And that is 256 square meters. Now we need the perimeter, but we're missing this piece. So we need to find that piece. What are we going to do for that? 16. This whole length is 16. This piece is 8. So what does that leave for that? 8. So that's 8 meters. So the perimeter is 20 plus 16 plus 12 plus 8 plus 8 plus 8. So let's see, let me add this. So this is 20, that's 20, so that's 40, 56, 64, 72. Did I do that correctly? I think so. All right, so sometimes you have to divide your shapes up into smaller shapes to get shapes that you can work with nicely. Okay, we all good? All right. Here's our homework. Sorry.